So thank you to everyone for joining today's Linux Foundation Decentralized Trust virtual meetup. Today we have a discussion about the newest project in the community named Smoot, and we have a conversation about Smoot that's being led by Weijia Zhang from Wanchain. And with that, I invite everybody who's here on the call. If you have comments, questions, or suggestions, please feel free to join in. You could use the raise hand feature, or you could type in Zoom chat, and we welcome your input. And with that, Weijia, please take it away.
Yeah, thank you, David. Thank you for joining this Meet Smoot seminar. This is the first seminar for Project Smoot, and Smoot is one of the newest projects in LFDT, Linux Foundation Decentralized Trust. And Smoot is interoperability project, and we're going to go through a lot of these today. And my name is Weijia Zhang. I'm a VP of Engineering of Wanchain, and I'm also the proposer and maintainer of this project, Smoot. So we are going to go through a lot of topics today. We are going to go through what is Smoot and its purpose, and also the challenges and why we want to solve the interoperability problem. And also we want to describe high-level Smoot mission and then key drivers. And then we want to discuss two important things, relationship between Smoot and other entities. Okay, one is EA, Enterprise Ethereum Alliance, especially the EEA Interoperability Specification. And another one, of course, is the LFDT. And then we're going to discuss the use cases, very important. And then we're going to discuss the technical side of it, architecture, the code base, the design, and some of the work that we have done already, and the roadmap, etc., and the deliveries. And then we're going to ask the audience, the whole community to contribute. And that's a main focus, the main goal of this seminar as well. So, of course, any project, the first question is why this project? What problem do you solve? Right? And we know that blockchain is not good at interoperability. It was designed to be silo, and they don't talk to each other. And interoperability normally means that things need to work with each other. Like 2 or 3 systems need to work seamlessly with each other meaningfully. But blockchains were not designed that way. When Bitcoin just came up, it's just everything is localized in Bitcoin node. They don't even talk to legacy systems. They don't talk to HTTP servers, anything. So you have to use Oracle. And then you have Ethereum coming in, you have Cardano, you have all these projects coming in. They are very, very isolated. They are silo. And at one point, the people believe that there will be only 1 or 2 blockchains surviving, and all the others are going to fade away. But things are not working that way. We are going to see thousands or hundreds or millions of blockchains coming out, both public blockchain and private blockchain. So it's very, very important to let them work with each other. And so the problem now is that we do not have common consensus across different blockchains. You have some blockchains working with POW, proof of work, and some with POA, proof of authority, which is enterprise blockchain or private blockchain, and you have POS, and then you have the POH or whatever, and many new consensus are coming in as well. So even consensus are different. There's no consensus at all across different blockchains. And then they have different programming language, and we know that you have, of course, Solidity, great for Ethereum, EVM compatible blockchain, but not good with Bitcoin. Cardano use Haskell, and then Python used by different chains, right? Watson. So they all use different programming languages for smart contract. So very difficult to make them interoperable as well. And then the cryptography curves, signatures, they don't recognize each other's signature. And then even wallet address is a different format. And then with that, this asset format are different as well. And then finality, okay, some blockchain can have 1 block finality, like BFT, Byzantine fault tolerance can have 1 block finality. But most of the POW and POS blockchain do not have that finality. And how can you kind of settle 1 transaction in 1 blockchain and that transaction to be kind of transferred to another blockchain and execute another transaction over another blockchain when they have different finality? So it's very, very difficult to have kind of seamless cross-chain transactions and interactions. But despite all these problems, all these hurdles, we still think there is a need and a way to have interoperability, to have a open standard and open source solutions for blockchain interoperability. And this is the mission of Project Smoot. Okay, so at a high level, we believe that the future of Web3 will be formed of hundreds, if not thousands, and I believe it will be thousands, or if not millions now, of distinct blockchain network, making the interoperability standard specification and open source solutions crucial for building unified decentralized network of blockchains. So we need to kind of network blockchains. It's just like a TCP/IP networking PCs back in Web 2. So Web 3, we need to unify, link all these blockchains together in decentralized way. So the mission of Smoot is to leverage the community effort of EEA, Enterprise Ethereum Alliance, and LFDT, then it's Foundation Decentralized Trust, to build an open source interoperability solution for connecting blockchains. So this is our mission at a high level. So to break it down to kind of more concrete objectives, we want to build Smoot as an open source project for interoperability, and we want to connect different blockchains, whether these blockchains are EVM blockchains or heterogeneous blockchains, like Cardano, Stellar, things like that. And we also want to facilitate the transfer of assets cross-chain. If you mint an asset in one blockchain, the asset should be able to be logged in that blockchain and then transfer the same value of asset to another blockchain. So that's asset transfer. And second one is to allow the data in one blockchain to be accessible to other blockchains. Data storage, as we know, are very, very expensive for blockchains because of the redundancy of blockchain node, right? Like in Bitcoin, you have 2,000 nodes or 20,000 nodes operating, storing the same set of data. And then for Ethereum, you have thousands of nodes storing the same set of data. So it doesn't make sense to have one set of data to be in every blockchain, in every node of blockchain. So it'd be great to have data in one blockchain and make it accessible to all the other blockchains. So that's a data transfer. And we also want to enable blockchain function source, meaning that you can sit in one blockchain, interact with one blockchain, and execute a smart contract command on another blockchain, on the target blockchain. That's almost like a remote function call across different blockchains. So we also want to make Smoot to be in compliance with EA interoperability specifications. So that is our main objective for Project Smoot. Then at this time, you probably know that Smoot means interoperability open source solution, but you may wonder why the name of Smoot. Why don't you just name Open Bridge or some fancier names? Okay, actually we did propose the project name to be Open Bridge, but David rejected it, saying that it has been used by someone else. And then we thought about other names, London Bridge, Golden Gate Bridge, Tower Bridge, and many, many famous bridges, but all of these are not good names because they have been used in other contexts. So we noticed an interesting story, which is related to Harbour Bridge over the Charles River, connecting the city of Boston and city of Cambridge and Massachusetts. A bunch of MIT students back in year 1958, they tried to measure the length of Harbour Bridge without any tool. So this guy named Oliver Smoot was chosen to be the measurement stick. So he just laid down himself on the bridge and measure toe to head, and then go to the next position, measure toe to head again, and then use that Smoot as a unit, and that is his height, which is 5 feet 7 inches. So after over 300 times, he had to be carried to continue measuring because it's so many times. And then they measure the Harbour Bridge length to be 364.4 Smoots with some measurement uncertainty. And later on, this Oliver Smoot became the chairman of American National Science Institute and also the president of ISO, which is a big person for standardization. So this spirit is good. Today in blockchain, we probably do not have many tools. We do not have many standards to work on interoperability. So we have to be innovative. So that's why we chose this name, and seems that people like it. So different people have provided many helps to Project Smoot, and then they also have different interpretations as well. Some of these are very good. Timothy Louis, the CEO of Wanchain, described Project Smoot in a very good way, saying that blockchains are fragmented already. And if you want to provide interoperability solutions, it will be self-defeating if you refragment the blockchain, make it even worse. So the interoperability solution should be interoperable. You should not make it worse. So that's why it's very important to have open standard, open specifications, and should avoid vendor lock-in. You should not have a kind of solution that so vendor specific and everybody have to follow that vendor's process and then API. So then when you move that solution to another blockchain, another vendor, it doesn't work anymore. So that is not good. So it's very important to prevent vendor lock-in when you try to solve the interoperability problems for blockchains. And then Daniela Barbosa, who is the LFDT executive director, emphasized the importance of open interoperable infrastructure. And I really appreciate Daniela's help in kind of bringing this Project Smoot to LFDT under LFDT umbrella. Yeah, and some of these quotes you can read it in the Smoot blog, and that was published 2 weeks ago. And also Right Wing Meslam, the executive director of EEA, Enterprise Ethereum Alliance, described the importance of open standard. And EEA has produced interoperability specification last year, and then we also have several implementations for this specification as well, several good use cases. And now we are kind of initiating this project with LFDT, and then we're joining forces together to have a even broader implementation of this specification. So we are working on the version 2 of the interoperability specification as well. And then we have an open source solution. And this will make the whole specification and the open source solution to be one. And this would greatly improve the interoperability of blockchain in this space. Yeah, so there are 2 cornerstones for Smoot. One's LFDT and one is EEA. So I just want to mention LFDT a little bit. LFDT used to be Hyperledger, and then it's kind of last year it's rebranded as LFDT with additional components, and this supports the open source development effectively. And I think this is one of the best open source community. And then the LFDT opens neutrality and flexibility and innovation, and also is very crucial for critical for infrastructure adoption of Smoot. So we are going to work under the umbrella of LFDT to promote this Smoot project. And in Smoot project, there will be several projects under LFDT that we're going to work closely with. The first one is the Pursue. Pursue used to be a EEA project as well, and then it was moved to Consensus and then donated to LFDT. So we're going to use Pursue as a client to initiate blockchains. So any blockchain that is running Pursue can have connectivity with other blockchains. Another project that we are going to work with, for lab we are going to work with, is the Harmonia project. And this is another interoperability project that supports EEA interoperability specification. So we're going to join force with Harmonia Lab and then have a kind of unified project. At least that's the goal. And also Cacti is another interoperability project that's built on the routing of cross-chain asset transfer and there are many components that we can leverage as well. So we are going to work closely with this project and labs with Smoot. And then EEA alignment, okay, some of the audience may not be very familiar with EEA. EEA is a member-driven organization that's focusing on producing standards and specifications for enterprise adoption of EVM blockchains, EVM technology. And Smoot is very, it aligns with EEA interoperability specification. We support that. And we are the main driver of EEA interoperability specification as well. And the first one has been published last year. And also, we believe that kind of the mission of Smoot actually is in alliance with enterprise adoption, which is the mission of EEA as well. So it's great to kind of develop the standard and then using LFDT project community to do an implementation of the specification, make it open source, make it a community project. And the EA has been kind of going on for several years already. We have a couple of publications. They are very good. Actually, we started to talk about interoperability of blockchain several years ago when not many people were talking about it. So basically, we started with interoperability. We call it blockchain interoperability use cases. We published the use cases of blockchain interoperability. If you're interested, you can search for EEA use cases for blockchain interoperability. You're going to see the publication. Again, if you're interested, you can send me a chat. I can give you a link as well. And then we also publish blockchain security guideline because we believe that there have been too many hacks with blockchain. There have been 2 years ago, there were almost 1.8 billion hacks with blockchain breaches. And we believe that the reason why there were so many hacks was that the blockchain security was extremely complex and people jump into this space too quick, without realizing how unsecure breaches could be, and there have been many hacks on that. So we published this article called Blockchain Security Guideline, and then we also published an article called Blockchain Decentralizing Guideline. And last year was a big year. We published the DLT Decentralized Ledger Technology Interoperability Specification, and that's just describing the common components for interoperability and describe the API that's needed, and then we describe the messaging format and messaging API and the process as well. So it have been a lot of work has been done with EA already, and so this project Smoot will leverage the specification and publication made by EA, and then produce a very good open source, open standard project. So this is a link to the EA's DLT, Distributed Ledger Technology Interoperability specification. You can read it if you are interested. And normally in that specification, we describe the core interoperability functionalities, APIs, and also describe consideration of finality, describe different how different blockchain can work with each other, and define the security and decentralization, etc. Yeah, now talking about use cases, what are the use cases for blockchain interoperability? In the use cases document that we published several years ago, we actually list 12 use cases, and some of those use cases are still very good. There have been a lot of them have been implemented by different companies, entities already. So we summarized this for Smoot. For Smoot, we believe that we need to have 3 things. One is the asset transfer. You should be able to kind of mint asset in one blockchain and let that asset to be transferred to other blockchain without friction. So that's one thing. Second thing is the data transfer. Okay, we should allow data to be accessible, to be reside in one blockchain and make the data accessible to other blockchains. And then we also need to build this cross-chain function, cross-chain interoperability, which means that you can have one application in one blockchain and then execute command on another blockchain. And also we need to support the public to public and public to private blockchain transfers. And kind of overall, the goal is to have like a write code in one blockchain for one blockchain, write smart contract for one blockchain, and make that smart contract accessible to all blockchains. So that will be the ultimate goal of interoperability. About architecture, okay. So there are 3 layers of architectures for Smoot, and this is kind of described in the DLT Interoperability Specification as well. So the first layer, the bottom layer, is messaging. When you talk about blockchain interoperability, you need to talk about messaging. If something happened in source chain, it needs to trigger action on a target chain. So you need to have a messaging mechanism to detect events and transactions in the source chain, and then kind of transfer that messaging to the other chain. And this messaging mechanism could be very generic, right? So you need to have this layer. And then you need to have a second layer, which means that from source chain, you should be able to construct an event, and then you can call the smart contract on a target blockchain. So you want to build that layer as well. It's a function called a layer for cross-chain operations. And then you have the third layer, which is sitting on top of a remote function call and the messaging, which is the application layer. So this is where you implement the business logic and implement the decentralized dApp on this. And this will include, of course, you include the business logic, include the GUI, and include the calling of the standardized API, etc. And then the architecture should support complex cross-chain functions directly. Yeah, and this is a kind of visualization of 3 layers, right? You have the bottom one is the messaging layer, and the second one is the cross-chain function call layer, and then the third layer is the application layer. So the bottom layer, the messaging, is to secure data and event exchange, which means that something happened in the source chain, and some data in the source chain need to be exchanged to the target chain securely. And a lot of things are needed in order to accomplish this. And then the second layer, the remote function call, is to establish cross-chain, cross-network operation executions to be able to call the other one. And of course, a lot of things need to be considered there as well. It may be the security. And then the third layer is the business logic and use case functionality. And we design it this way so that there could be kind of a modularization, like to make it modular, make it reusable. So people can just build the messaging layer, or people can just build on the function call layer and build a framework. And then the kind of application teams can build the application on top of these layers, just try to make it as modular as possible. Yeah, and this is a little bit flow. Just to visualize the working flow from users' point of view and the backend processes. Okay, so the left side will be a user, and then there's an application layer. This is the top layer, and then there's a secure network, and then there's messaging layer that connect the source chain and the target chain, and then there's the target chain over there. So there's user, application layer, source chain, messaging layer or function call layer, and then the target chain. And then the user will initiate a transaction calling the application, and this could be just a GUI in the Web2 interface. And then that transaction will be sent to the source chain, and the source chain would process the transaction and confirm the transaction and send the result back. And I think at this point, this is like a single chain operation. Most of the single chain transaction is done this way. But because this is cross-chain operation, we need to go beyond that. So the source chain will emit the event, and then the messaging layer will detect the event. I'm here right now, emit the event here. The messaging layer would detect the event, verify and sign the event. So the messaging layer need to be trusted or have a way to be trusted, or it could be trustless, but there need to be a penalty if they do something wrong, because these messaging layers are extremely important and they are off-chain. So it's very important to have security on these messaging layer. So they need to verify, sign event, and generate a proof and send the transaction with some function call parameters to the target chain. And the target chain will verify the proof, execute the cross-chain function call, and then confirm the transaction, finish that transaction, and send the transaction back to the messaging layer. And then the messaging layer can then return the result to the application, and then the application can then return the result to the user. So this is a kind of end-to-end transfer of user requests to the source chain, to the messaging layer, to the target chain, and all the way back to the user. So this is the whole process flow for cross-chain transactions. So, and then this is kind of a topology, or kind of more holistic view of Smoot project components. So the top layer is still the user. And then when we talk about decentralized application, they can interact with a wallet such as a MetaMask or a mobile app or a desktop application. And those could be browsers as well. And then using TCP/IP is interacting with cross-chain applications, and then they can perform data transfer, asset transfer, and command transfer. So these are kind of operations a user can take. Of course, when they kind of customize it, those data asset transfer could be in different ways. For example, setting ERC20 token, setting NFT token, buying NFT token, or doing exchanges, etc. And then after these cross-chain applications, it go to the smart contract, and this smart contract could be in public blockchain, could be in private blockchain, it could be EVM chain, or could be a non-EVM chain. It just make these smart contract to be able to reside in heterogeneous blockchains. And then the relayers are the ones that connect blockchain with blockchain. And these relayers can have different kinds of mechanism. It can have a multi-sig mechanism where multiple relayers can have their private key, sign the signature, sign the transaction, verify the transaction, verify the event, sign the transaction independently. And then there'll be a quota saying that 5 out of 7 need to be valid signer, and or 7 out of 10. So these are multi-sig. And then MPC signing mechanism is a little bit different from multi-sig. With MPC, multi-party computing signature mechanism, there's only one address, and all these signers share the same address, but none of them have the private key of that address, and they can still sign the transaction together. But because nobody owns the private key, so nobody can kind of decrypt the transaction or manipulate the transaction. So MPC has proven to be very, very secure for working as a relayer mechanism. And these have been implemented with Wanchain solution for ES interoperability specification, and we're porting these solutions to Smoot. And then there's also GKP synchronization, and then GKP proof. You can also use a GKP relayer to transfer transactions from source chain to target chain. And we also want to support like-kind and some of the hybrid method, etc. So this is the overall topology of Smoot components. Yeah, and then the code base, because we share this because we want this project to be a community project. So there'll be core teams working on the major component of the project, and there are peripheral teams working on different things, and everybody can contribute code to this. So it need to be very, very straightforward. So the whole Smoot repository need to be very, very straightforward. So here we have several high-level directory structure for Smoot code base. First one is the application, and this one we want it to be very, very open-ended, to be generic. Anybody can come here and create the application directory and work on specific business case. Right? For example, pay and delivery, delivery versus delivery, those use cases could be implemented in application layer. And then the contract layer, this will be the contract sitting in different kinds of blockchains, written in different languages. So this will be kind of a directory, over the high-level directory for all the smart contracts. And then there's an agent and route. These will be the actual relayer. So there will be a framework of relayers, and that's applied to all the blockchains, and there will be kind of chain-specific or language-specific modules. So there'll be framework directory, and there'll be module directory. And module directory can be contributed to different teams, and if they have expertise on that. And then services are the things that they are kind of utilized by Smoot system. For example, some of the RPC servers need to be there, some of the SDKs need to be in services, API need to be in services, etc. So these are the high-level directory structure, and we hope that because this high-level directory structure is so flexible, and experts in different teams can contribute it freely here. Okay, and then deliveries. Okay, what do we deliver? What is short-term and long-term delivery? This is what we are thinking right now. First, we need to implement different mechanisms. For example, today I just mentioned that we have multi-sig, we have MPC, but we do not have a full implementation of GKP yet. And then the light client, we have some of it, but no a full implementation. And then hybrid is we're still working on that as well. So we want to kind of enhance that, deliver a different kind of mechanism for blockchain transactions. And then we also need to work on a smart contract for both EVM and non-EVM chains. We have implementations for EVM, easy, but non-EVM is kind of challenging. We have implementation for Stellar, and we have some implementation for Cardano, but for other blockchains, we're still working on that as well. So we need to have a smart contract for different blockchains with different architectures and consensus. And we also, they are doing service, the whole framework, and the kind of restructured framework need to be developed. And then we need to develop blockchain applications, the top layer. For example, some people may want to come in, develop DEX, decentralized exchanges, NFT marketplace. Some of the gamings are using this technology. When I say these applications, I mean the blockchain applications, the blockchain gaming application, okay, blockchain NFT marketplace, things like that. So these applications need to be developed. Yeah. So the delivery, okay, we want to have a phase-based delivery. The first phase, of course, is migration. Okay, we have a very broad code base already for the implementation of EA specification. We want to move the implementation to LFDT. We move the major part of it already, but once we move it, people come in saying that, hey, I want to have this change. We want to have that change. We are doing the second version of migration for the code base. And then we want to design the code base to be vendor agnostic, which means that it should not be a solution from this entity, from Wanchain or from Adara, from anyone. We want to make it vendor agnostic. If there are some vendor specific thing, it could be in modules or it could be in services that are very, very related to a particular vendor service. And then we also, we want to enable modular component addition by contributors. And we also want the code base to be designed for community contributors as well. So this is the first phase, the migration. And second phase is convergence. We we want, actually, this was proposed earlier when we submit this project to LFTT, and some of these may be changing right now. So when we proposed to FFTT, we mentioned that at some point, maybe the cacti connector can be added and we can join forces together. And we also, the Harmonia project is another good project that we want to work with. So we can have conversion on these things, these kind of things are also, and also we need to add GKP to the Smoot messaging. GKP, I think FTT still doesn't have GKP project yet, so we probably need to invent this, or a third party who have expertise in this can donate their code to this project, and then to fulfill this requirement for GKP relay. Yeah. So this is the second phase, the convergence and unification. And the third phase will be the adoption. This is where we want to have the real world application to be built on top of the Smoot project. So we want to build enterprise solutions based on Smoot framework. We want to develop end-to-end use cases, including GUI components. We actually want to have some examples saying that, hey, this is the GUI as well, because a lot of time project develop framework, but without releasing the GUI as open source. You have to reinvent the GUI every time. So we actually want to have end-to-end use cases, including GUIs in our code repository. And then we also want the developer to be able to leverage Smoot source code easily and build on top of the API that we defined and implemented. And then we also try to enable third-party app development using Smoot as a framework. Yeah, and this is Smoot is an open source project. We definitely want all the other teams, community members to join the effort. So we have a technical steering committee, and then the regulation, the governing process have been published by David about Smoot project. So you can look at it, what is the rule for governance there. We welcome experts to join our TSC. And we'll also welcome contributors to provide code for Smoot project, and we'll also welcome developers to learn about the Smoot working process and enhance contributions, and then also early adopters are welcome, and then the maintenance effort to help improve project overall. We need these people as well. So we are open with this open source project. We open everyone who want to contribute to the interoperability of blockchains. Yeah, so you can, this is just visualizing what I just mentioned earlier. And here are some links. Okay, so there's we have published a blog, and the blog is called Meet the Smoot, one framework to connect all chains. And you can see the link here. In that link, you should be able to see the Discord channel link, the GitHub link, and the meeting information as well. So I did not list here, and you can just go to that blog article, and then you can read the whole article. And at the end of the article, there's a list of resources there. And also to know more about the EA specification, you can go to EA's website and look at the spec of DLT Interoperability Specification over there. And this specification is evolving as well. So I'm going to take some time for questions. I saw some people posting questions here already. Let me open up chat here. Hi, David, do you have anything you want to say? Or have you read these questions? Okay, just a moment, let me see. Okay, the YouTube is streaming. Okay, that's good. Okay, they have a question here. Anuj, what are smart contracts and how they are defined here in blockchains? Well, smart contract is a programming language for blockchains. So I'm trying to answer questions here in the chat. So this question is about what are smart contracts and how are they defined here in blockchains, right? So blockchain programming language is a smart contract, and smart contract are different from a regular programming language because smart contract has to run in blockchain and run on every node of the blockchain. And these smart contracts are written in different languages. And so you can view smart contract as the programming language for blockchains, and they run on every node. Yeah, I think I answered the question in the chat. Are there other questions that you want to ask? Okay, if no question about smart contract, the question asked by other people, I actually published a book called Smart Contract Development. If you're interested, you can search for Weijia Zhang, Smart Contract Development. I published a book that is almost 450 pages, a textbook for that. You can read that book, or if you want to send me an email, I can send you the link to that book and give you more information about the book. How to program in smart contract. Okay, got more questions coming in.
I was just going to share that if people have any additional questions after this call is over, that there are channels that you're welcome to join. Smoot, as Weijia was saying, Smoot has a welcoming community. Please join the regular Smoot calls. Put a link to the Smoot calendar and the Zoom chat, and you can also join the channels on Discord. So, if you have conversations that you want to have or questions after this event is over, please join us there. But I see other people had put some questions in Zoom chat too, so.
Yeah. Yeah, and then I have a question from Sonana team before how to smooth interact with SVM and the EVM. Okay. So this is a kind of connected heterogeneous blockchain, right? In EVM, we are very familiar. You have all these APIs, you have these solidity opcode, and then you can write the smart contract, and then you emit events as well. So same as EVM, SVM. So we just have we do not want to alter the core layer of these blockchains. So we are going to have events defined in SVM or EVM, and then the Smoot will be a layer that's off-chain that will interpret these events and then transfer the event from one chain to another chain. And this event will follow the format, or the proof will follow the format of EA specification. So we kind of achieve this core-chain operation through an off-chain layer, and through the interpretation and reorganizing the transaction and re-verifying the transaction and pass that to the other chain. And then is Smoot a secure connection? Well, it depends how you define secure connection. The Smoot, of course, need to be secure. That is for sure. But when you say secure connection, if you are talking about chain-to-chain direct talk, no, that's not the case. The Smoot is not a project in the core layer. It's a project off-chain at the smart contract layer, EVM layer. So we do not enable this tunneling. If that you talk about the direct connection to the other chain, no, that's not Smoot. Smoot is an off-chain component that interpret what's happening at the EVM level and then pass that to the other chain. And I suppose you can build a tunneling mechanism, but that will require hard fork of the blockchains. So that is not the goal of Smoot. Smoot want to do interoperability without hard forking the blockchains. So hopefully this answers your question, but Charlton, you're welcome to communicate further after this seminar. I think you probably have more to ask here. I definitely see where you're coming from. Yeah. Well, thank you. Some people could give good comment. Can they handle exceptions? Well, yeah, well, that's a good question. Yes, exception is very, very difficult. Finality, exceptions, how do you do error handling? Those are extremely complex. I think you need to read, it'd be good for you to read the EA specification. There are some things that we just cannot have a full solution. So, for example, finality. If one blockchain has block one finality with basically fault tolerance, another blockchain have 30 block finality. How do you do cross-chain transaction over there? We do not have a perfect solution over there. And then same with exception as well. What if the source transaction emit the event and it can roll back? Like those are very, very complex problems. We do not have a full solution for that yet, but that's why we want to have this as an open source project. At least we can consider these factors, and these are extremely for security, right? Because chains can roll back, and how do you deal with this? And at this time, with all the experience we have, it seems to us that as long as the transfer value is limited, it depends on the transfer value. If the transfer value is much, much higher, you want to handle more exceptions and you want to wait more time for finality. But if it's a small value transaction, if there are some people who are waiting to take risk, for example, relayer who are waiting to take risk, it is okay. We can have kind of measure the risk over there. For example, it's just a $10 value transfer. The relayer can transfer those kinds of transactions in 2 seconds, and saying that if this failed, if the source chain rollback, or if this transaction gets something wrong, I'm willing to take risk because it's just $10 value anyway. So those can be solved through relayers commitment or staking. Okay, Smoot Ripple in the good place. Yeah, Smoot Ripple is a good place. And by the way, yeah, David mentioned that. I give a link. Thank you, David. Yeah, that Smoot Ripple is changing because once it's published, people coming in saying that, hey, it needs to be done this way, needs to be done that way. We have the second version coming in very soon. Yeah, I think that's agreed. That's it depends on the value, right? Vitalik in last DevCon meeting, he mentioned 2-second interoperability, which means that he want to have interoperability cross-chain transfer finished in 2 seconds. And we know this is not possible because the finality time is way more than 2 seconds. But there are two things that can be done. One is the computational verification, but that can be done only in one type of blockchain. Another one is to measure the risk, saying that, yes, I can transfer that in 2 seconds, but if something failed, I'm willing to compensate for the loss. So that is a good way to kind of balance the risk and the speed here. Well, thank you. Oh, there will be millions. There will be millions of blockchains. Okay, I was kind of humble there. I said there will be hundreds, if not thousands, of blockchains, and here we have we have one person coming in saying that there will be millions of blockchains. Okay, they even verify that it's more important to have interoperability to deal with these millions of blockchains. Okay, please drop your book link. I can search it right now. But just okay, yeah. This is Amazon. Okay. Are there other questions? If not, I'm going to stop sharing here. And if I have one more second, I'll find my book link. I will drop it there. Yeah, it's the link to the book. I just copied it from Amazon. So yeah. So David, well, thank you very much for hosting this. And thank you all audience. Well, it's great discussion and great to be talking about the Smoot project here. And really welcome you to contribute to this project. It is fully open.
Yeah, thank you for presenting and thank everybody for joining. And again, yeah, hopefully this is the start of a conversation about the project. And again, as Weijia was saying, we welcome you to get involved. So looking forward to seeing you more going forward. So thanks, everyone.
Yeah, thank you.
Bye.